Okay, everybody, welcome to the March 25th, 2024 version of the Astro Cafe. And I'm very pleased tonight that we're going to have an Arizona theme. So we're going to start off with Callie Salmas. I'll introduce her. And then Dave Payne will talk. David Lee has some observations he'd like to talk about. We'll try to convince Chris Gainor to tell us something happening up with Hubble or Webb. And if we still have time, I have a little something, but it's a bit fluff. So I told Callie that she could pretty well talk as long as she wanted to.
That was a mistake.
That's a mistake. So, I met Callie, oh heavens, about 5 years ago. I was interviewing students to work in my lab. And while I didn't actually need Callie's services, when she started talking about herself, I pulled in a colleague of mine and said, I think you want to hire this person. And indeed he did. And then after that term, then you just kept working with us for years and years. And then you had this existential crisis where you're going to go into geophysics or back to your roots in astronomy. And you found this wonderful gig in Arizona at the MMT. And I hope you're going to tell us lots about it. So here's Callie Salmas.
Okay, we'll see if I can figure out how screen sharing works. I think I want you guys to see this.
No, you don't touch it.
Now you can.
Now you move
Oh, okay.
us over to the right.
I think that might be on mine.
Just give us a
Oh,
moment,
perfect.
try and get this.
And then you hit that's 9
3 by
squares.
3 mini, yeah.
Hit the 9 squares at the top. And then you can resize out the whole thing. Great, okay. So, Callie Salmas.
Wait, I'm second guessing my choices. It'll be fine. Hi, so.
Oh, can everybody hear her?
That looks like nods. We'll take it. Yeah, so this is my adventures at the MMT Observatory. We are jointly owned by the University of Arizona and Harvard-Smithsonian Center for Astrophysics. Some of these photos I have stolen from other people and they are credited appropriately. People have had many more hours up there to take pictures than I have so far. There we go. So who am I? I'm a UVic alumni. I have a physics and astronomy degree that I slowly crept my way through. I did lots and lots of outreach. I think I've met a number of you through that. I spent a lot of time at the DFM 32-inch on Bob Wright. I helped with school tours. I helped with a couple of the star parties. And I've been working at MMT since May of last year. You will note the mirror selfie. They are very hard to take in a telescope this size. Still working out how to do that better. You might be asking, where is the MMT located? We are 55 kilometers south of Tucson. I use kilometers because that was the test zone for switching everything into metric. And so it's actually all in kilometers entirely south of Tucson. It's very convenient because we drive up a Forest Service road to get to the summit. It's about 19 kilometers and we use two-way radios to make sure we don't crash into each other and fall off a cliff. And it's all in kilometer markings, so I have an idea of how far away someone is. Our summit's at about 8,500 feet, and it takes about an hour and 45 minutes to get from downtown Tucson to the summit of the mountain, depending on the weather and how many people are coming down the mountain when you're trying to go back up. And you will see in the picture, I have labeled Nogales, Mexico. That is a view from the summit. You can see Mexico, which is very upsetting when it's snowing. And there's no light pollution laws on the Mexico side of the border. Nogales straddles the border. And you can kind of see a trail of lights a little bit to the right of the city. That's in Arizona. There's city all around that, but you can't tell because of the light pollution laws. And you can see a really sharp line from up there where Mexico starts because it's just really bright.
Can you tell us what MMT is?
Yes, I can. Well, there we go. We'll go here. Go back to the other slide. MMT used to stand for the Multiple Mirror Telescope. When it got first light in 1979, it had 6 1.8 meter mirrors. So that's the same size as the Plascat telescope here. It was a combined 4.5 meters collecting area. In 1998, they decided that they could do better. The mirror casting lab in Tucson had learned a better way to cast very large mirrors. And so they made us a 6.5 meter mirror, which is what lives in the building today. That makes it the 14th largest in the world. When they redid it and made it one mirror, they couldn't call it the Multiple Mirror Telescope anymore, but branding. So they kept it as MMT, and that's just what it's called now. It doesn't stand for anything.
Monster mirror.
A little bit. The Large Binocular Telescope kind of has a beat for that though, because they've got two 8.4 meter ones. So go back to this slide. We are located at the Fred Lawrence Whipple Observatory. So it's got telescopes at 3 different levels. There's the summit at about 8,500 feet, where we are located. There's what we call the ridge at 7,800 feet. They have a number of other telescopes. Not all of them are on that list. That's just the list that's online, but I know there's at least 2 more. And then we have a visitor center down at what we call Base Camp, along with the Veritas telescope array. So those are 4 12-meter mirrors that look at gamma rays. Yeah, so both the summit and the ridge have dorms with full kitchens, and that's where we live. I typically stay up at the summit or just below it, but when the weather is really bad, we've been moving down to the ridge lately. And with El Nino, it's been bad. It is actively snowing there right now.
Ouch.
MMT, I like to call a bit of a guinea pig telescope. I actually learned about it in school here because we did a lot of things first. We were the first large optical telescope to use multiple mirrors. One of our operators actually worked there when we were a multiple mirror telescope, and it sounds like quite the endeavor. At the time, we were the largest mirror ever cast by the Stewart Observatory Keras Mirror Lab. They now cast larger. 8.4 meters is about the maximum. In December, they just cast the 7th and final mirror for the Giant Magellan telescope, which will go in Chile. We were the first telescope to successfully pull off having a deformable secondary mirror for adaptive optics. They decommissioned it in, I think, 2018, 2019. But there's a group up there. They were up there this weekend working on making a new deformable mirror for us. Very complicated. I'm glad I don't have to run it yet. We're pretty sure we were the first telescope to have a co-rotating building. You'll notice that our telescope barely fits inside our building. When you're in there, there's about a foot of extra space between the telescope and actually hitting the sides.
Wow.
Apparently, when you build a telescope, the building is like 30% of your total cost. So if you have a smaller building, your telescope is overall cheaper. It is really stressful standing in there watching it tip down though, because it looks like it's going to hit something. There are some lifts that sit in the front, and there's a zone marked by tape where they can sit. And we were one of the first large optical telescopes to use alt-azimuths instead of equatorial. At the time, computing had just kind of caught up to the point that we could control a telescope with all 3 axes of rotation. And they gave it a try, and so far so good. We're using the original mount, so we pray the computer that is older than me doesn't break every day.
They haven't changed the computer.
No, it's still using the original computer. When they did the conversion, the reason they actually stopped with 6.5 meters was because they didn't want to redo the building or the yoke that holds it in place. And 6.5 meters was the biggest they could fit in there. And so I'm quite certain it's the original computer that controls the mount. The telescope
Works.
moves,
The
still
works
works.
don't fix it, yeah.
It's like $10,000 to replace a tiny little piece of it too. So we really want it every day. Yeah, so to run this thing, we're actually a pretty small operation compared to a lot of the other telescopes around. People keep telling me Arizona has more glass pointed at the sky than almost anywhere else in the world. Every time I talk to a new astronomer, I learn about a new telescope, so I believe it. So we've got a mix of people that work solely in town, solely on the mountain, and then the night staff. And then some people that cross in between those, for a total of about 30 people. So we're pretty small. I say at least 5 instruments currently on site, because these are the 5 that I've seen with my eyes. There are still places I haven't seen that could have more instruments hiding. So we have Binospec, Hecto, and Mirrors. Those are things that I run. Blue and red channel is run still in classic mode, where the astronomer themselves does all their own operations. Mirac, I don't know much about. They're using it for the adaptive optics system right now to test it. There's another instrument called Pisces that might still be in the building, but it's like a 1-foot square box. It could be hiding anywhere. If you saw this place, like there's stuff in every corner, I swear. We have 3 secondary mirrors, which is kind of neat. They swap them out depending on what instrument goes on. Binospec, Hecto, and Mirrors use the F5. It's very wide field of view. Blue and red channel use the F9, and the F15 is the adaptive mirror. I have seen that one. It looks very intense. It has, I'm not sure how many actuators, but it's a whole quest. They've been working on it for years. And in addition to our 30 people in Tucson, we have the instrument PIs, so primary investigators, and they're in Cambridge, Massachusetts at Harvard. They are moderately high up on the list of people I sometimes have to wake up at 3 in the morning. We hope we don't call people, because that means something is very wrong. So this is our most recent staff photo. It gives you a bit of a sense of scale of the telescope itself. With the red arrows, those are our town staff. The man in the center is our director, Grant Williams. Town staff consist of our software team, our administrative team, and people that manage our queues for our instruments. So they're the ones that interface with all of the astronomers. They deal with all of the chaos of helping them submit their proposals in a way that makes sense, and in a way that is actually going to get them usable data. And they, most importantly, deal with the astronomers when they complain about, why aren't you looking at my science tonight? I don't want to talk to people about that. They try. The green arrows are for our mountain staff. Various techs, they honestly keep everything running as smoothly as possible. They are up there almost every day of the week, no matter the weather. How do they get up that steep road in the snow? Not too sure. Without them, we would be completely lost. We have our instrument support group. They split their time between town and the mountain, and they are specific to keeping our instruments alive and happy and well. They cool them off for us before they put them on the telescope. They run the instrument exchanges. I interface with them a lot. They fix things when I break them. And then the night staff. So we're missing people from every group. We have 6 night staff. We have 3 telescope operators and 3 Q observers, which is what I do. I will explain the difference in a minute. Yeah, so this is kind of a representative split. I apologize to anyone who's colorblind. I couldn't think of a better way to do arrows. So not too big, but a really solid staff. Everyone's really dedicated and tries their best to help us out, even if it's 4 in the morning. And the only explanation I can come up for what's happening is everything's just really glitchy.
So Kelly, where did you take that picture from?
Oh, one of our software engineers, Dallin, is super into photography, and he had this crazy boom system with a counterweight on one end, and then he raised the camera way up and somehow got it high enough up to take a picture of us. So that's taken from the ground, and this is the 2nd floor of the building.
Well done.
Dallin is magic. I have to wake him up sometimes, and I always feel bad, but he always fixes my problem in about 10 minutes. So I wanted to give an extra shout out to our Mountain Day crew, because without them, this telescope would slowly grind to a halt. They wash the mirror, they run instrument exchanges, they fill the giant liquid nitrogen dewars for us. We cool all of our cameras with liquid nitrogen and then heat the cameras up to their appropriate operational temperature. which is between -110 and -120 Celsius, depending on the instrument. They do a lot of pest control. As you can imagine, having a rotating building that sits open for up to 14, 15 hours a day. The rats have moved in, the mice, amongst many other fun critters. They're really cute until they try to crawl up your leg at 4 a.m. They snowplow. They do pretty much everything that we need. So a few pictures. Why would you shovel snow when your building can shovel it for you? There are blades on the corners of the building specifically for plowing snow.
Cool.
This sign claims there's an alarm. I have never heard an alarm when rotating. There's a lot of weird legacy stuff. There used to be a laser guide star, and so they have lights on the outsides of all the doors that go into the telescope chamber that say "Do not enter when flashing." Those don't go on anymore, which is nice. And I mentioned mirror washing, which may frighten some. It frightens me, coming from here where I was told you can't wash a mirror, you can just re-illuminize it. They take super soft cotton mops about every 6 months, dump a bunch of water and soap on the mirror and just kind of dab it until it looks clean. Then they rinse it off and dry it off with some fancy giant blow dryer looking things.
Whoa.
I haven't been up for one yet, but
So that's the drain hole in the middle, is it?
they take all the instruments off, which is good. Normally that is where the instrument will be getting its light. We put a weird bubbly corrector in it at some points to correct for atmospheric dispersion, but all the water does drain out there. They've got plastic around the edges to try to keep water from going underneath. There's 104 actuators sitting underneath it for active optics. And one of my coworkers told me last week that he used to be day crew, and he said one time they went to pull one of the panels off the back of the telescope after a mirror wash, and the person doing it just got completely soaked, and all the water came out of that panel.
Oh,
So, you know, it
Good.
seems fine. We re-illuminize it ideally every 5 years. I think we're pushing 7 right now, but that's a whole ordeal and very expensive. Speaking of water on the mirror, a thing I never expected to hear at a professional observatory was, I don't care if you get a little bit of water on the primary, just open, from the director himself, because there was snow and ice sitting on the roof that we didn't think would fall into the chamber, but we weren't sure if it was going to drip on the mirror. So apparently, water is not as big of a deal as I thought. Instrumentation, I'll give a quick overview. There's lots of words on these slides. I promise I won't read all of them. Just the instruments I use. This is BinoSpec. It is my favorite thing because it is new and it does everything on its own. If you want to run calibrations, you just toss them in the queue. It turns on all the lights, puts the screen in place. It just does it. Most of its fixes are software fixes, which means I just go reset a server somewhere. Everything is mirrored, thus Bino. So it has 2 CCDs, 2 sets of filters, 2 sets of gratings. We typically only use one of the CCDs because one is in kind of rough shape and we just haven't replaced it yet. Yeah, it does mostly spectra and a little bit of imaging. We do a lot of supernova and a lot of spectroscopy work here. The supernova are particularly fun because we get notifications if an astronomer notices that one has happened recently. We get a notification and we will try to make that our next target. So we see a lot of supernova that have gone off within the past 24 hours. We have Hecto. It has 2 instruments technically, Hecto Shell and Hecto Spec. They live in a bench room upstairs. This is a multi-object spectrograph that is fiber fed. So there are 300 fiber optic cables that get fed through that kind of black swoopy bit up to the 3rd floor where the spectrographs live. We try not to switch between them in the middle of the night. I'm told it has happened. I am dreading that day because to move the fibers from one side to the other is very heavy and takes a lot of work. There are,
I'm gonna drop.
well, thankfully they're suspended from the ceiling. which is helpful, but the little gate is up so that we don't accidentally step on it, because they are quite sensitive. This instrument has 2 robots that reconfigure all the fibers in about 5 minutes. One time it started taking longer than 5 minutes, and that's when everything got glitchy and I had to wake people up at 5 a.m. Just after daylight savings time too, so Cambridge was only 2 hours ahead of us instead of 3. So this is the focal plane that all the fibers go onto. It's a metal
So
plate, and each fiber optic cable has a little magnet on the end of it. And they just get pulled into place with the robots and then left there while we do our observations. It is very delicate. The robots get very angry. I always make sure to go in and say hello to Hecto in the afternoon and ask it to behave nicely. This is the view when you're looking at it from the side. This is what I see when one of the robots has decided it doesn't want to play nice. So we look inside to make sure that the fiber is in a safe position and not being held by the little gripper jaws. And then we call someone and they help us back out of whatever position it's gotten itself into. Having to fix this instrument is always interesting because the chamber is wide open and it's very cold and sometimes quite windy, and you're trying to talk to someone on the phone at the same time. This one also, I should mention, is hopefully getting decommissioned in the next 2 years and getting replaced with a new instrument that they're building for us, which will be similar in concept, but instead of having robots move all the fibers into place, they'll actually each have a little motor so they can move in a small circle in their prescribed zone. Which means if one motor dies, we just turn off that one and we continue observations. Oh, there we go. The robots have circles, so you can see them a bit better.
So are you gonna tell us more about what that does later on?
And what's that? Oh, right. Sorry. In terms of like what kind of observation?
Yeah, why are you moving these fibers around?
Oh, right. Yes. Okay. Sorry.
It's really cool.
Yeah, it is. So each fiber gets positioned where the star or part of the galaxy that the person wants to observe is located in the field of view. So it's the same idea as Binospec uses what we call a slit mask. So it's a piece of metal with a whole bunch of little lines cut into it. Each line corresponds to the star. This one, instead of having to make a new mask every time you want to observe something, you can just make a new program and tell the computer where to put the fibers. The person that uses this, Charlie Conroy, has some crazy survey he's been doing for over a decade to look at, I believe it's something to do with the halo of the galaxy and stars out there. And we will take easily 10,000 spectra a night for him.
Oh, wow.
He'll get the whole night. If it's winter, I'll do 12 of his fields. Each of his fields have about 250 spectra. So yeah, 10, 20,000 spectra a night. It's
Are
a
you
little bit.
placing the cords over the star? So
The computer tells it.
Is it?
Yeah. I am very spoiled. The computer does much for me.
You don't have
Um,
to set each one by yourself.
Oh, no, definitely not.
So
There's
how long does
some-
it take to reposition the fibers?
5 minutes.
Wow.
Mhm.
Oh, that's good.
It's very fast. We're a little convinced it's getting a bit slow with age. Takes a little bit longer than 5 minutes. The biggest issue I've ever had with this one was it felt like it was taking longer to reconfigure every time, but it was the first weekend I'd been left alone with it. So I couldn't decide if it was just me getting more tired as the night went on, or if there was actually a problem, and then I got a timeout error on my software. And I realized there was a problem and had to call people to fix it. But typically they're quite fast. They do as they're told. We're very careful about how long the robots sit on for because they heat up quite quickly. Especially as we move into summer months, we have to start paying attention to that again now because there's less of that ambient cooling. Even though we're on top of a mountain, it still has hit about 25 degrees Celsius outside, dropping to about 10 at night in the summer. It's currently sitting at -5 right now, so we've got quite a range. But yeah, this is used for people who just want absurd amounts of data. The new instrument that's being commissioned is also for that scientist. He wants to do a full sky survey. So Magellan is kind of like our trade. We can use instruments, we trade instruments back and forth sometimes with them. And so they're building 2 of the new instrument, one for us and one for Magellan. And so we'll get a full sky survey, which is a little insane.
Well, you're doing the Northern Hemisphere part. of the
Yeah.
Survey.
Yeah, they're pushing to have that out in 2 years. It feels a little overly ambitious. So, and then it'll probably take, I would guess, 3 or 4 months to properly commission it and get it operational. So hopefully in 3 years' time, we'll be getting data for the Northern Hemisphere. The third instrument that I get to run is called MIRS. I don't actually remember what it stands for. I know IRS is infrared spectrograph. This one's pretty, I admittedly don't know much about it. I'm supposed to start learning. I have 1 night on Sky with it of training, and I'm hopefully getting 2 more on Wednesday, Thursday this week. It's not a great picture. This is the only one I had. It's looks kind of like a giant white egg. And the whole thing is cooled with liquid nitrogen. The rest of our instruments, we only cool the cameras, but because this one is looking at infrared, we need everything to be cold.
I'm just gonna interrupt you and
Yes,
tell people here that coffee is on.
please drink all the coffee. It's good. Yeah, so MIRS is a little bit of a mystery to me still. It's a lot older than the other instruments, and so you have to manually set up on a lot of your fields. So whereas the other instrument, BinoSpec, will move the spectrograph and move the slit into where I want it to be, this one I have to use pointing stars, finding charts, all of the kind of more old school style of astronomy, which I'm both excited and terrified for. This one I have a lot of experience putting liquid nitrogen in, and I call it a liquid nitrogen farm because it'll go through one of those large tanks in 2 or 3 days. Normally it takes at least a week to go through one of those. Now, the most interesting part, what night staff do. I would joke and say this isn't what I do, but I definitely was sitting with my feet up eating a bag of popcorn last weekend. So can't say it's not. So at our telescope, it takes 2 people to run it for nighttime operations. We have a telescope operator and a Q observer. Interestingly, I attempted to be a telescope operator 2 years ago, and they decided that I was not the right fit for the job, and then invited me to apply for the Q observer position later that year. And it's definitely the better spot for me. The telescope operator drives our telescope. Anything that has to do with the telescope or the building is their domain. That means dealing with the mirror, dealing with any issues with the mount. Making weather calls is the biggest thing they do. During the night, honestly, 75% of their job is just making sure that the weather is fine and that we're not going to break anything. So mirror temperature is really important. We do run ventilation to attempt to cool our mirror and keep it as close to ambient temperature as possible. Humidity is really important. If it starts to creep above 90%, we risk getting condensation on the mirror. As much as they tell me that water is okay sometimes, apparently covering the whole thing is frowned upon. Lots of ice, snow, rain, clouds. I moved to Arizona. I thought I was done with winter. That was not the case. Our operators work on a 1 week off, 2 week off schedule. They can predict their schedule as far out in advance as they want. My position, we run the instrument. It tends to be a little bit more software. Looking at data, making sure everything looks okay. Picking targets. If it's science, I'm probably the one doing it. I also get to make closure decisions. Mine are slightly less stressful. I care a little bit more about outside temperatures, the internal temperature of the instrument. I don't want things to get too hot or too cold. And the internal humidity of one of our instruments because it has sodium lenses of some variety. Turns out salt and water don't like each other. Nominally, my schedule is 5 nights on, 10 nights off. Ish. Lately, it's been 4 and 8, but I still end up only working about a third of the time. Yeah, so we work very closely together. Ideally, we sit in the same room so we can bounce ideas off of each other. Q observing seems way less stressful than telescope operating. Last weekend, we pushed very close to the limits. We had frost on the outside of the building, and as the operator told me, as long as it sticks there, we're fine. So I decided that my instrument was fine and the rest was his problem. So this is my station up at the summit. This is running the hectoshell GUIs. You can see I have 2 very large TVs telling me what the telescope is doing and what the weather is doing. Those are also mirrored on the operator's side of the room, just at the other end of the table. Their setup is pretty similar to mine, but with obviously different things on their screen. I think I did put another slide just to compare the GUIs on the screen. You can see this one's a little bit busier. I supervise a lot of things during the night. I do a lot of babysitting of stars. Our telescope runs in what we call Q mode, as opposed to classic operations like the Plaskett does. Classically, an astronomer would come to the telescope. The instruments tended to be a little bit simpler, easier to understand from just some pieces of paper with instructions on them. But if the weather's bad, you're out of luck. That's your time on the telescope. And you can't control what kind of weather you're going to get. Whereas in Q mode, we have a staff observer, and the astronomer doesn't usually come hang out with us, which means our instruments can be more complex because we spend all of our time running those instruments. If there's bad weather, no one gets data, so we all struggle together. And you can set stricter parameters, especially on your seeing and what kind of weather you want. Our seeing is generally pretty good. We like to sit around 1 arc second. Some people set that as their limit. They tend not to get as much data. And limits on seeing also will vary depending on what kind of observations that we're doing for someone. So a usual night for us is we do an afternoon instrument check, make sure nothing broke while we slept during the day. Also make sure the day crew turned off all the lights because they're not good at that. We check the weather, make sure everything looks okay. Some of our instruments we don't like to start up all the way if we're not going to get on sky, just because it's a little bit harder on the instrumentation. We run as many calibrations as we can during the afternoon so that we don't have to deal with them when we can actually do science. And then we open at sunset to let things start cooling off and settling. We start our observations a little bit about an hour after that. And then we observe all night until about 45 minutes before the sun comes up, assuming that, there's no clouds and there's no adverse weather. Then at the end of the night, we fill liquid nitrogen dewars so our cameras stay nice and cold. And then for 2 of our instruments, we run dark calibrations at the end of the night. The reason we fill liquid nitrogen in the morning, because everyone's favorite thing to do at 6 a.m. is play with cryogens, is that some of the instruments will lose nitrogen if you tip the telescope all the way down right after it's been filled. So we tip down to open, and we'd lose a ton of nitrogen if we fill right beforehand. So, most importantly, how to get data. There's a sequence of events here. They are roughly the same for every instrument. In essence, you choose a target, you set up the instrument, send the coordinates to the operator so they can go there, set up a few extra things that I'll describe later on, take data, take calibrations, and then move on to another target. This view, by the way, is from where I get to sleep at the dorms. It's pretty spectacular waking up and opening the door to that. Not during the night, though, because blackout curtains are your best friend.
What does establishing the wavefront mean?
Yes. Sorry, I will explain that. We have actuators on the back of our mirror for active optics, which account for gravity as we tip the telescope down to different elevations. But we also provide a little bit of correction based on how focused the starlight is as it comes in. And there's a whole process. I admittedly don't understand it too well because it's not my domain. But they're able to apply, I believe it's spherical, coma, and astigmatism based corrections to the actual primary mirror in order to try to focus the light better. I have a slide that shows what the patterns that they look at to do that.
Star to do that too, or
No, they used to.
they use?
They used to. We no longer have a laser. I am equal parts happy and sad about that. I like lasers. Lasers are fun. There's an Air Force base just north of us. That makes the laser way less fun really fast. There are also planes that take off from Nogales and fly up to Phoenix, and they fly right over top of us. And you have to have spotters, and you have to have FAA approval every time you want to turn your laser on. I'm hoping they might give us one when the adaptive secondary is fixed, working. Kind of want a laser. I think it'd make really good pictures. Honestly, this job already kind of feels like a video game, and I feel like a laser would make it feel more like a video game. But good. When I first started, we were observing from just below the summit in what we call our common building. They had separated the operator and the observer during COVID so that they could reopen, and then had never moved us back up there until just before Christmas. Because they needed to re-roof the common building. And it felt way more like a video game down there because there was no feedback whatsoever. You're just sitting in a room kind of like this, clicking your buttons on your screen, and something on the little diagram of the inside of the instrument moves. And then some data pops up. And sitting up top, there's a lot more feedback. The building spins. There's a couple spots on the track that clunk a bit. So you hear that. There's air compressors. It's good. It's much better. So this is our weather monitor, just a slightly closer view of it. This is fairly typical, I'd say. Our software engineer, Dallin, who took the picture of the staff photo, designed this and built it for us. You can see the track that the telescope can follow, that green spiral around the white building in the middle. The animation does change depending on the elevation of the telescope and whether or not it's open. What else is good about this to highlight? One of the two pictures on the far right, you'll notice, are not quite the same. The red dot is in different spots, and that's because one of them is actually a movie that plays the last 20 minutes of weather. It's hard to see any clouds because there weren't any clouds, and the moon is up. But clouds are very, very obvious on this sky cam. They appear a little bit sooner than you can see them with the naked eye because the cameras are a tiny bit into the infrared. But I rely quite heavily on this screen to tell me exactly what's happening. Temperature, humidity, and wind are what I most pay attention to. Once we hit 30 miles an hour, I'm not allowed to look into the wind anymore. Turns out having a very large secondary mirror will attempt to turn your telescope into a sail. Not allowed, sadly, because it'll try to override the building drives. And once the wind starts gusting to 50, I'm closed and I'm done for the night.
So your targeting decisions are actually quite crucial in order to optimize the amount of time telescope is used.
Very much so. My job is incredibly future-proof because as far as I know, no one can make a robot that can make those kinds of decisions. I do have a whole slide on targeting decisions too.
Okay.
This is the other screen that I do have to pay a reasonable amount of attention to. We call this our telstat. This is everything that the telescope is doing right now. I cannot tell you what target it's looking at because I stole this a few nights ago when the Adaptive Optics group was doing their stuff.
But do you have millisecond tracking?
I don't know if it actually tracks to the millisecond or if it just pretends it does. It is quite accurate though. We do brag that we are one of the best at pointing and sitting on target and actually staying on target quite precisely.
Okay, so for astrophotographers, what sort of precision are you looking for with your tracking?
Oh, you'd like to be within a couple of seconds of your guide anyways.
Couple of seconds,
Yeah.
and these are looking at
Or,
Point.
Well, I mean, a good guiding would be less than a second.
You're going for 0.5.
yeah, on the ASC card, anything below 1 second is just useless, right? You get the most out of it. second. And for the 8-inch house,
Do you have a rotator on your camera if you're taking images that deal with all that shit?
We do, yeah. So we have 3 axes of motion. We have the elevation with just the telescope drives, which are, I should mention, completely silent. You can stand in the chamber, and if you're not looking, you could get hit with the telescope because you can't hear it move. And then we've got our azimuth, which is the spin, and that's done with 4, the whole building sits on 4 train wheels underneath that ride on a track. And there's 2 motors down there. Sorry, I just got to go down there last week, so I'm trying to remember. Yeah, there's 2 motors that run it. The drives just got replaced last year, so we're still troubleshooting those a little bit.
How'd they make that sucker level all the way around?
So carefully.
That would be, that's an enormous.
They actually took a bunch of
that could-
rock off the mountaintop too.
Yeah.
When they built it, the summit was not quite as flat.
Oh.
And then it took a long time, I
To level
believe,
it out.
to level it all out.
And so like railway track, it would have little shims under it in places.
I don't think it did. It looked pretty flat. It wasn't quite a railway track. It was just like flat metal chunks
Okay.
that were all quite level, and they sit on top of cement. But it's rail wheels.
Yeah.
And if one of them breaks, there's a way to jack it up. So you jack up that corner of the building so you can fix your wheel. Thankfully, hopefully never my problem. One of our recent hires on our instrument support team commented that she felt that my job was way harder than hers because my job description was basically the same as hers, but with all the night stuff included. And I said, yeah, that's because my job is take data. If someone calls me and says, go do this thing, I go do the thing, even if I've never done it before. But is there a question? Is that what the raised hand means?
Oh, yeah, Lord.
Hi, I wondered what the difference in sunsets were in the year. Like what the differences are for the amount of time you have on the telescope.
I think it's only about 4 hours difference in terms of sunrise and sunset across the year, like 4 hours in terms of total night. Our shortest nights are, I think, 7.5 hours, and our longest are 12. So the earliest sunset I saw was about 5 p.m. and that was stressful because I wanted to sleep till 3. And the latest sunsets are about 7:30.
Okay, thank you.
Yeah, no problem. It's nice because it's a bit more consistent than here. 12 hours of darkness was enough because that meant about 16 hours of actually doing things. Sleep is precious. I shouldn't say actually doing things because when I'm sitting on target, I'm mostly just kind of hanging out and watching guide stars and making sure nothing breaks on its own. So there's a bit of downtime. It's also El Nino, so we got a lot of time of just sitting and doing nothing this winter. People pay a lot of money to go on snowy mountain retreats, and they paid me money to go on one, so can't really complain. But yeah, sorry. So in addition to the azimuth and elevation drives, we do have a rotator on the back of the telescope, and it rotates the entire instrument. So there are limitations depending on the instrument. The one with all the fiber optic cables, we obviously can't rotate quite as far as the other ones. Turns out cables don't like being stretched when they're that expensive. Important things I tend to pay attention to on this page include the seeing. We have wavefront sensors in the telescope, and those tell us an approximate seeing value. The one with the sideways arrow is on target, and the one straight up is corrected to be at zenith. And the seeing monitor just stares at Polaris all night. Oops. Yeah, sunset, twilight, those times are important to me at the starts and ends of my night. I try to end about 15 minutes before the sun, the twilight for sunrise, the one on the lower, the 5:30 a.m. one, just because it starts to get bright really fast, and if I'm looking at a faint target, it doesn't like it. the offsets are things that I send to the telescope from the guiding setup. It's a little stressful if I think too much about it, because sometimes you feel the building move when I apply the offsets. And I can change the focus sometimes, which is also stressful. Thinking too much about how large of a telescope I'm using and how much money everything costs is generally a bad idea. I got to help commission a new piece of instrumentation for Binospec, and the scientist in charge was out visiting, and he decided to tell me how much it was worth as it was in my hands. I did not want to drop $135,000 of scientific equipment. He laughed at me for the next week and a half. So target consideration. Oh, sorry.
All those lights to be green.
Oh, yes. Yes, we like the lights to be green. Very much so. Those lights, thankfully, are the telescope operator's problem.
Oh, okay.
They become my problem. Passing down. But generally, they just tell me, no, you don't get to take data tonight. I get to make decisions. If the seeing goes above 2.5, we tend not to observe. I've seen it as high as 7 arc seconds, at which point it stops reporting its values. I don't know how high it got. We have a large mountain peak to the northeast of us that is slightly taller than us. And if the wind comes from that side and decides it's going to be very slow, suddenly the air just gets incredibly turbulent. The other problem we do have is, being a tall mountain, we develop lenticular clouds. They will creep up on you. I think almost every operator has accidentally ended up with a cloud in the chamber. It's just what happens. We try really hard not to collect clouds, but and sometimes there's inversions and the clouds are below us. We tend to stay closed if the clouds are below us because they rise very fast. I've had it happen once before where the operator came running in and told me I had to shut everything down right now because the clouds were there. Yeah, so it's a lot of information. I usually don't have to pay attention to too much. The many varieties of time are relevant to me because one of the instruments I actually have to pay attention to the RA and deck if I'm picking new targets. I learned that coordinate system very fast. But target considerations. The astronomer submitting data or submitting for data will prioritize things according to their program. So that gets taken into account. Where it's located on the sky. So the elevation, is it rising, is it setting? How much longer is it going to be up? How far away it is from the moon? When it's going to pass across the meridian, so that line from north to south. With an Altaz telescope, it can only spin so much, and the rotator tends to get a little bit angry if you try to look at something while it's transiting. We can't actually look at anything that's directly overhead either because the rotator freaks out. Doesn't like that. How much time they have left in their program. Each astronomer is given however many nights of time or however many hours. Once they start getting more time towards their program than others have, their targets are less important to us because we try to spread the time equally throughout everyone. Have to look at what the sky looks like, see what the seeing is, so how twinkly everything gets, the cloud cover, the wind, humidity. Target constraints from notes, they'll give me a whole bunch of instructions. We're working on reducing the number of instructions they give us to something less like an essay. Some of them will really severely restrict what they want their data to be taken in, which then means they don't get data and then they get sad. And they send us emails asking why we haven't looked at things. Some of them tell me to do things that the instrument can't do. One of my new favorite things is telling an astronomer in my head in the middle of the night, no, you don't want that, trust me. Like someone asking me to position their mask wrong on the sky. And I say, if I do what you asked, you'll get data for a minute and then it'll stop. And then obviously how much time is left in the night. I don't want to start a 2-hour target if I've only got 45 minutes left. It's a lot to keep track of. Thankfully, hope the slide is still next. Ah, yes, I have a magic tool to help me. This is what we call the dispatcher. Our software engineer, Dallin, is incredibly proud of it, and I'm told it's one of the best in the industry. This is how we pick all of our targets. It runs, at least for mirrors and for binospec. Hecto's a whole other kettle of fish. I have this really cool map. Everything's color-coded based on priority. Green is good, red is bad. If you're really desperate, you can look at a red target, but you might get an email later saying we didn't actually want you to look at that. So you can click on the targets on the map and it'll give you this box at the top. Oh, here we go. So this box at the top has all of the target information from the astronomer. So it tells me the coordinates. I care less about that. The operator cares about those. It tells me how bright it is. It tells me what sort of mask I'm going to use. This is our IFU, our integral field unit. That's the $135,000 thing that I was scared of dropping. It has a whole bunch of fiber optics in it that essentially take spectra for the entire object across the field of view and then turn it into some sort of data cube. I'm just glad I don't have to look at it and figure it out. We put filters, we put gratings. The most important part for me is the exposure time and how many exposures they want. That's one of the spots I get to say, no, you don't want this, because if they ask for an exposure greater than 20 minutes, I say no, because you get too many cosmic ray hits.
Oh.
Yeah, little tiny considerations that make having a Q observer a little bit nicer, because we know what's good for each instrument. Other instruments are less bothered by that. You can see there's a big list of targets to the bottom left. I can also choose my targets from there instead of the map. And there's a score. So those 13.43, 12.57. If this were the live page, which I don't have open because my boss is using it tonight and I don't want to mess with that. If you hover over, it tells you why it's scored it a certain way and what considerations are being made. So it's a really handy way to take a look. If conditions are good, you just start at the top and you go down and everything's good. We add notes to everything. You can see I've said clear, seeing equals, I haven't filled it in yet. Took 6 exposures at 900 seconds, it's 15 minutes. Those are notes to the astronomer to tell them what we did, what the conditions were. If I've changed anything about their program, if I said, no, you can't have a 35-minute exposure, I'll put it there. Sometimes they want me to look at like 11th magnitude stars and they want a 5-minute exposure. And I say, no, please don't break my camera. Because we're a 6.5 meter telescope, our targets are very, very faint compared to anything you'd use with the smaller telescope. The brightest stars I guide off of are 15th magnitude, which you could not see with the 32-inch telescope at UVic, because most of our stars are just picked off the main stream of light. So that took a little bit to get used to.
What magnitude can you, is it the limit of magnitude that you can get a spectrograph for?
The limit, the faintest I've seen is about 26.
The brightest?
The brightest, it depends on the instrument. The brightest I've personally done with binospec was about 11. They asked for a 5-minute exposure. I gave them 20 seconds. It was good. It was fine. It was almost overexposed still. But in terms of the telescope itself, they'll point at almost anything. The adaptive optics groups point at the full moon, which frightens me a little.
Yeah.
But they want bright targets to do their alignment. So my coworker actually had to argue with them one night because it was too cloudy and the humidity was borderline. And so he didn't want to open, and the operator gets final say. In our weather restrictions, it says in giant red letters at the bottom, do not fight with the operator. Don't push back ever. And this guy was kind of pushing back, and my coworker finally said, okay, we'll go outside, and if you can point at something bright in the sky, we'll look at it. Yeah, he couldn't find anything. There wasn't even the moon that night. So yeah, so they like the moon. I don't. The moon is in my way frequently. Hectoshell, it's fine because hectoshell is a very high resolution and extremely narrow wavelength instrument. It's using an Shell spectrograph. So it's looking at, I want to say, less than 50 angstroms for their spectrum. So that one we run during the full moon all the time. I ran binospec during the full moon once because Hecto had broken and it was a really bad time. A cloud decided to sit over the moon and the whole sky was useless for about an hour. But yeah, so picking targets, always a good first step. I try to have another target lined up and ready to go before the previous one finishes, just to try to, not lose time. There's only so many hours in the night. This is how I schedule things for Hecto. It is much less high tech. Someone else makes me a schedule and I print it off and then I draw all over it to remind myself what I need to do. This is the instrument that made me finally learn what RA and DEC were for. Because if I have to pick a new target, that's what I use to choose which part of the sky I'm going to look at. So for example, sometimes I've trashed an entire schedule for the night because all my targets were to the south and that's where the wind was coming from. And so I just started over and made my own that only looked north. Hecto has a lot of calibrations. It looks more chaotic than it actually is once you get used to it. And I add really helpful notes to myself when I learn things about when to add more time versus when to add more exposure. As the person training me taught me, sometimes it's just vibes, which sounds terrible in the context of science, but seems to work out. So to set up on a target, sometimes you have to go back up to zenith to reconfigure the instrument depending on what you're changing. Things that rotate don't really like rotating at not zenith at angles. And then we kind of bounce back and forth between myself and the operator to actually set up on the target. So I'll send them coordinates and then they adjust the pointing, which is just what the telescope is pointed at. It helps center the target in the field of view. They go to a really bright star to do that. I think they aim to look at something brighter than 10th magnitude, I want to say. They start complaining when their stars get as faint as mine. And so that it helps center the target. It makes guiding really fast. And then they pass it back to me and I choose guide stars from a list that's just given to me by the software. And then I make sure that there are actually stars there, get the system locked on. If there are not stars, sometimes we have to adjust things. For some reason, astronomers are bad at getting the right epoch and proper motion of their standard stars. So sometimes there's no guide stars. But generally, that all happens pretty quickly. And then the guiding just keeps the telescope pointing at exactly the same spot on the sky for the duration of the exposure. Mostly so that the rotator doesn't start freaking out and going too fast, I believe. We can set offsets for that get sent to the mount and they adjust the telescope ever so slightly. Guiding, that is also how we offset our targets to the right part of our CCD. Our CCD is made up of 4 chips and we try not to put things on the boundary between those chips. Astronomers don't like it when their spectrum runs in the middle of things like that. And then, so the wavefront is applying forces to the primary. So as I said, they run spherical coma and astigmatism error corrections. So those images along the bottom are what the wavefront camera sees. I think there's a dot for every actuator, so there should be about 100. I quite honestly,
What's the displacement of this?
I don't actually know. I'm sorry.
Millimeter
The actuators are millimeter.
Yeah.
So they raise the primary, it sits on hard points during the night, and then they raise it up and adjust the collimation and stuff before they start for the night, and I believe it's a couple millimeters. If they apply too many forces, it panics and it just drops the whole thing. And even that couple millimeters is loud enough that you can hear it below in the control room. I haven't been up there when it's panicked yet, but I'm told it's quite the ordeal. And it takes at least 20 minutes to get things going again. So we try really hard not to panic it. Yeah, so you can see a few different wavefront images. I'm still learning how to read them because they're not really my problem, but I want to know everything. So the one on the left is obviously super out of focus. The seeing was really bad that night, and we weren't actually getting wavefront corrections because the software couldn't find single dots. It just looked like a golf ball. The purple one, so the fourth in, is kind of flexing in a little bit. It's hard to see on the screen. I don't remember what they apply to that. I've recently started to experience with different color patterns, which is why it doesn't match the rest. The one on the far right is what we want it to look like. We want it to be a bunch of dots. We want it to look like a donut, basically. And not be flexed in weird or kind of blurry around the edges. The wavefront improves our local seeing a little bit, which lets us get better data. And then flexure is this magic thing that Binospec does, where it actually moves the CCD around within the instrument to improve the focus by placing it in the optimal position for that target. I don't know much about it other than that's what it does. And if it breaks, you're kind of out of luck because the instrument won't let you take data without it. And this is why we have Q observers now, because this instrument would be tricky to run if you were seeing it for the first time. You'd lose a lot of time your first few nights to figuring out what's going on. So once you're on target, you can take data. We take the requested number of frames with the requested time. Like I said, sometimes I tell them that they're wrong in my head and adjust what they ask for in order to give them optimal data. If they require calibration frames, we take those. So flats are just like the flats that you would do for astrophotography. And then the Gainors are a calibration frame that let them calibrate their spectra and adjust for any redshift that might be occurring. While we're taking the data, I sit and I babysit my guide stars. I make sure they're still in focus. I make sure they're not turning into donuts with poor seeing. I make sure there are no clouds interrupting my data. Astronomers don't like when I send them pictures of clouds. And then as the data comes in, I really quickly make sure that it actually looks like data. I don't necessarily know what they're looking for unless they've given me a sample spectrum in their proposal. But I make sure it looks like a spectrum and I make sure that there's data there. Because like I said, they get a little mad when you send them not data. And before the target's done, I update my notes to tell them what I did. I charge overhead, which is just the time spent configuring for their target, setting up on it, reading it out, the data files, and any calibrations. This is helpful because it makes them more inclined to make sure that their data is good when they're sending it to me and that their coordinates are good. It also means that, you know, if you've picked a target in the Milky Way and I'm going to have to fight to get guide stars that aren't too close to another star or have problems, you're going to get charged a little bit more time to your program. It's just kind of accounting to make sure that we know where all of our time is disappearing to and to keep us honest and efficient during the night. And then I pick something new. And I have it sitting in our on-deck program where I can mess around with it without actually doing anything to what's currently happening. And then you repeat ad infinitum until the sun comes back. And yeah, that's what I have prepared. It's kind of cool. It still feels pretty surreal to be up there doing this job. I was talking to the newest operator earlier today, and he said that 2 years in, it still feels not real. So I don't know if that ever goes away. But
Thank you. And again, there is coffee and Kathy made it, and so please partake of it. And we are good for questions now. I see Leslie with his hand up right away.
Hi. So you would start a typical day night of queuing at maybe 2 o'clock in the afternoon?
that's ambitious in the winter. I was setting my alarm for 2:45 at one point. Ideally, I start 2 or 3 hours before sunset. So 3 o'clock in the winter. It's currently drifting closer to 5 o'clock when I actually get moving.
Okay. So you can be there for up to 16 hours.
Yeah, so I
And
actually
you're sedentary.
Mhm.
Do you not find it difficult to
Stay awake.
stay awake? Because this is, I used to be a meteorologist and I would be working at night.
Yeah.
And I found it was much more difficult to do a night shift in a sedentary situation where you're sitting at a desk monitoring monitors and so on,
Mhm.
that it would be if you were doing something physical.
Yes.
So I just can't, we sometimes have 12-hour shifts, but that's 16 hours is a long time.
It is. So the first night is always the worst because you have to get there. And that takes like 2 hours. So I usually wake up around 11:30 or noon, pack my bag. I have to bring all my own food, so I've got to put that in the cooler, pack the car, drive up the mountain, switch vehicles at base camp too, because we don't drive our own cars up. Why take your own car on the really rough gravel road when you can take a government car? People also move out of your way faster if you have government plates. But yeah, so the first night's always the hardest because you're up earlier than you want to be. I switch back a little bit towards the day schedule when I'm on my days off. I usually wake up around noon or 11. There's a treadmill that I can walk around on. That helps.
Yes, I bet.
I tend to just kind of like bounce around the room a lot and annoy whoever I'm working with. It's easier now that I'm at the summit and I can talk to the other person.
Yes, yes.
Last week, the first night we got clouded out and I tried to have a nap at 4 a.m. Most of my coworkers drink coffee. I don't. I just kind of suffer. I don't know. Wednesday's gonna suck because I go home tomorrow and then I'm at work on Wednesday night.
Oh,
So
yeah, wow.
you just kind of suffer through it and you hope that what you're doing is the right thing. And then
It also would affect your cognition and decision-making
Definitely.
skills as you go
that's why
through
there's
the
two
night.
of us.
Yeah,
If one of us is about to make a really bad decision, the other one will stop them for sure.
okay.
After that first night, I tend to settle pretty okay. This week I'm only going up for 3 nights, which is hard because by the third night is when you're finally feeling settled and into the groove. At the start of April, I forgot the eclipse was happening and I didn't book it off, so I get to work for 6 nights. And switch instruments and switch operators at the end for the last night. So there's always changes and stuff to kind of keep you on your toes, but
So you're gonna sleep
Yeah.
through the eclipse?
yeah. I saw the last one, so I can't really complain. But we don't get much of it in Arizona anyways. One of my coworkers is going to Arkansas to see it, and she's never seen one, so I'm like, you should go. The other one might have booked it off for a sporting event, which I'm less happy about.
So there's 3 of you?
Yeah, there's 3 of us that operate, or 3 of us that observe and 3 operators. And with the operators working for a week and then off for 2 weeks and us doing sort of a 5-10 schedule, it means you never work with the same person all the time. I say this as most of my nights are with one person and he's gonna hate me by the end of the semester. But it keeps things kind of fresh, and we joke that our operators are kind of like the 3 bears. I didn't know 3 people could all be opposite of one another. So it's a little bit jarring. So it helps a little bit to keep you awake when you switch instruments all of a sudden halfway through your shift, or you switch operators and it's the way you interact with them has to change a little bit. Like one of them is very particular and she wants things a certain way and you have to be very precise with your language. And then the one that starts after her just doesn't care about anything. He's like, whatever, just tell me that you sent me coordinates so I know to click a button. So that helps with the awakeness. Mostly I just suffer. Poke yourself a bit to try to stay awake. The mice come and try to visit, and that wakes you up really fast. Go stand outside in the wind, that helps. Oh, and when things break or if something goes wrong, that really helps with the being awake. Nothing wakes you up faster than looking over and seeing an error message on your screen and having to figure out what just happened.
Any questions from the internet land? And if not, as a final question, how typical is this of major installations? I mean, I had never had a candid view of somebody saying about all the things that could break. You know, usually
Probably
we
should've
had
said
somebody
something,
from the
right.
Canada Transaway telescope and it was all like roses. And I know that they have their issues too. But it's,
I think it's pretty typical, like, most of our problems are fairly well documented and fairly well solved. Most of the time, if something goes wrong, I search my email and someone else has had the problem. Currently, because I'm still new and I don't have an email backlog past last year, I call the lead Q observer a lot. The current goal is to make it through a shift without phoning him. So close last week. So close. Yeah, it's an aging telescope, it's an aging building, things go wrong. I'm sure CFHT and Gemini have similar issues. Because I'm new and I'm still learning, that tends to be what my brain focuses on a little bit, because I live in fear of having to wake people up. It's not a fun time for anyone, but the people that I wake up tend to be very calm and collected, which helps.
I think you'll find it much easier if you just use like a 6-inch or 5-inch refractor.
There's like a 5-inch one on the
I don't
side
know
of the
about that.
I almost brought my 4-inch up last weekend because I knew the conditions were going to be bad enough that I probably couldn't observe with the 6.5 meter. But my 4-inch would be fine. And then I didn't end up bringing it, which was good because we pushed to the limits and we did observe every night that we could, that it was clear. There is a little like 5-inch bolted onto the side that was used for some project at some point.
Oh, yeah.
It's just still hanging out there. I don't know how to access the camera that's on the back, but I might play with that if I can. Yeah.
So when you first go up to the altitude, how long does it take to adjust to the altitude?
Not too
Not that
long.
long.
I adjust pretty quickly. I get really dehydrated. That's the
Mhm.
biggest thing.
Yeah.
If I don't drink enough water, I wake up in the middle of the day with leg cramps. But the altitude does contribute to the first night kind of sucking. Yeah, I don't have as many problems with it. One of my coworkers gets headaches and stuff, so sometimes she'll go sleep at the ridge because that's about 1,000 feet lower, and that seems to help. Yeah.
we have a question from Margie.
I have a related photo to share if we're at the end of questions.
I have another question.
Okay, last question.
Okay, how did you get a work visa to work there? Or is this a free trade agreement, position type of position, because it's technical?
I kind of have a visa. I try to figure this out all the time. So to start, I found the job on Twitter just to start the ridiculousness of this whole thing, and ignored the part where it said they weren't accepting international applicants. I just decided that didn't apply to me. So I'm on the same kind of visa that they bring down students and research exchange people on. So I can stay for 5 years. I say it's not technically a visa because I'm Canadian and it's part of, what is it called? It's not a visa. There's some sort of like work agreement between the two countries. So I didn't interview for it.
Sounds like the free trade agreement.
Something like what they call a green card.
No, it's not quite a green card. It's they call it a J1, so it's a research exchange. So technically at the end of it, I'm supposed to come back to Canada for 2 years before I'm allowed to work in the US again. I also can't attend school while I'm down there. And I can't apply for permanent residence or a green card or citizenship or anything like that. People keep joking with me. They're like, what if you get married? That'll fix it. But no, still have to come back for 2 years. But I toy with the idea of doing a PhD while I'm down there because Noir Lab is across the street. And I need to change my visa, and I figure it's America and money will change. Money can fix most of your problems. But it's through the university. And I think, yeah, they did it all for me. They FedExed me a package and I signed it. They FedExed it to my parents' house, and then FedEx lost it and delivered it to the wrong house. And then I called them And they're like, well, do you know what your package is? I don't know how much effort we want to put into finding this. And I told them it was a US work visa and it showed up within about 5 minutes.
Mhm.
I scared them. Yeah, so I showed up at the border. I drove down. I showed up at the border crossing in Alberta and they signed off on it and said, have fun. I stayed for 5 years. I have to get a signature. I have to tell people every time I leave the country, I'm only allowed to leave for 4 weeks at a time. And I have to have a signature from my like responsible officer at the university. I call her my keeper. I get a signature from her and it's good for a year. So this will be my first time crossing back into the US after having been gone for more than 6 months. So please keep me in your thoughts tomorrow that I get out of Vancouver.
Yep.
Oh, that's very
Well-
interesting. Thank you.
Yeah.
Thank you so much. This was
Yeah, no
exceeded
problem.
all expectations. It was great.
Good, I'm glad. I'm sorry it's a little chaotic and unpracticed, but.
Okay, Margie.
Okay, I'll give this a go. I'm going to share the screen. Okay, click on desktop 1. Press share,
TV on.
share your screen. There we go.
Oh, you might have to move.
You might have to
the
move.
people image.
All right, can you see that?
Not yet.
Not yet. Okay.
Did you take that picture? Remember it?
No,
You can't see that either, right?
yeah,
No.
just hold on. Have to move the Zoom.
Sometimes it takes a moment, but
I thought it was maybe me, but I.
okay, I'll go back.
You have to move the Zoom screen. don't you?
Not till she shares, I don't think.
Oh, it's not been shared.
All right, so there's the Zoom screen. Share screen. Click on desktop top 1. Yeah, press share. Mhm. And then when I say it, oh, it says allow Zoom to share your screen. Open system preferences, security and privacy to grant access.
No.
Really? I haven't done that before. Haven't had to do that before.
Your has to do it.
Dirty credit.
Back.
Okay,
Yeah, Margie's using a Mac, they must have upgraded.
yeah, okay,
Oh,
Start
you've been
it to make
upgraded,
the-
Margie.
Okay.
I
Yeah.
did, yeah.
Margie, should we have Dave go now and you'll try to do this later?
Yeah,
Okay. Anyway,
Dang.
we'll catch you later, but
wants me to, wants me to leave the meeting, so,
it is now our great pleasure to have Arizona Part 2 with our own Dave Payne.
Sure.
And his share did work, yay.
There we go.
Okay, do you know the trick of going more? Can I go down to the more?
So I'd like to talk about Astro-tourism in northern Arizona. So when deciding to travel down to the States to escape the rain for a period of time, we were looking at places, and I had never been to Arizona before. So we decided, and part of that was I'd never seen the Grand Canyon before.
Sorry, I'm just trying to,
Get our full screen, so now that should be enough. So just, yeah.
Good.
Well, there we go.
I almost said something really bad. Go ahead, Dave.
That's what you and I were.
Yes.
Here we go.
Okay, it popped out of the,
Popped on the sideshow.
out of the slide.
There you go.
There
I
it is.
forgot the page down. So while we were just hearing about south of Tucson, somewhere around there. And over here is Kitts Peak. We decided to focus, my wife and I decided to focus on Flagstaff.
Right.
Partly for the Astro-tourism, but partly for the Grand Canyon and to hike in Sedona. But, and then spend some time down in Phoenix. So right here is Flagstaff. This is the location of the Lovell Observatory. And it's at 7,000 feet. And I found out after we booked everything that it's one of the snowiest places in the United States. It wasn't too snowy when we went. And I'm going to talk about that in a second, but first I'm going to talk about just an hour's drive east of Flagstaff is the famous meteor crater. It's also got another name that escapes me, the Behringer crater. Now it doesn't look like much when you're driving up to it. It looks like a little pimple on the plateau and a prairie, desert prairie. And then when you get there, you're confronted with this mile-wide hole in the ground. And you can see from the satellite picture on the left here, it indeed looks like a crater on the moon. And is in fact the world's most best preserved crater there is. So the rim rises about 150 feet off of the plain. So until you actually get to the rim, you don't see anything. And then it's 560 feet deep and a mile across. And this was, when this was first discovered by some settlers, they said, oh, this looks like a meteor crater. And so one of the things they did was start looking for the meteor, because they figured it was quite sizable, and that much iron and nickel would be worth something, as well as the curiosity as to what this was, drove the drilling of a well here to look for the meteor, which they didn't actually find. And I'll get to that in a second. This is just another view of the same thing, just the other side of it. You can hike to the bottom, but I was still getting altitude adjusted, so I didn't really feel like it. But if you look at the opposite way, you'll see these mountains in the background. Some of these are cinder cones, volcanic cinder cones. So that was the big controversy with the crater. Was it volcanic in origin, or was it a meteor? And three things finally convinced everyone that it was in fact a meteor crater. One was they found, this is the largest chunk of the meteor. It's about the size of a bar fridge or something like that. That was found. It was found quite a few miles in a canyon to the west. The other thing that told them it was a meteor crater was there's minerals found on the ground there in these outcrops that had only previously been found surrounding underground nuclear testing. So that convinced them that there was a big event here, a big explosion happened. And the third thing explains why they didn't find the meteor. It was mainly vaporized when it hit the ground and created this hole, and it sprinkled the entire area with small chunks of iron filings, I guess. So this is not the place you want to be in a lightning storm. And there's quite a visitor center there. It replaced, a few years ago, it replaced the old visitor center. And that one burnt down from lightning. So the meteor that hit was 150 feet across, I'm sorry. And I was kind of interested in this site, and I highly recommend you go. The visitor center is outstanding. The two reasons I was interested in, I studied the Sudbury meteor crater, which was the creation of created the mineral rich deposits in Sudbury, that are mined there. But just to give you a sense of scale of that thing, the meteor that created that was 6 to 9 miles in diameter. It's much older, and the crater was over 100 kilometers wide. So this is a mini version of that, but still being a mile wide, it was very impressive. And the other thing I was involved with was an actual underground crater, which was a little bit bigger than this, in Viewfield, Saskatchewan, that contains some oil reservoir that we went off of, and you could see it on seismic, and you could see it by the stratigraphy it went through. So when this rock hit, any geologists in the crowd, it actually took the top sedimentary layers and flipped it upside down, so the stratigraphy goes in reverse. You can see that some places in the Rockies where the actual folds, there's actually folds in the stratigraphy. But here, it was kind of new to be exposed to it. There has been about 100 feet of fill in this thing. So it was actually deeper than it appears here. It was actually back in wetter times, it was actually a lake. So enough of that. That was just personal, one of my favorite things to see. Then I went in Flagstaff a couple of days later, went to the Lowell Observatory, and there were domes all over the place. In terms of, again, a wonderful place to visit. The one on the left, and I'll get back to this, was my favorite to look at. It's the Jiffy Pop dome. And anyone, the age would understand why it's called that. But it was actually cool. The temperature was a concern, so it's actually, the telescope is actually underground, and that's why that was done that way. And what looks kind of not too impressive was this dome, and this was the first large dome that was built on the grounds by Lovell himself, and it kind of doesn't look like too much from the outside, but when you get into the thing, before I get there, they had the entire history of the observatory was all laid out. Fantastic. These are the original telescopes that Percival Lowell brought to Arizona before Arizona was a state, scoping for locations to set up his observatory. And on the right-hand side, this is the Discovery telescope. It's over 5 meters. The mirror on that one, not quite as big as the one we were talking about before. Yeah, it's close. And they call this the Swiss Army knife because there's 5 instruments carried at one time at the bottom of this. So you don't have to change the instrument, it just rotates it in place. Didn't get to see that. I think the floor is supposed to rise in the building and lower in the building. So I didn't get in the building, it was closed. But I think it was also broken at the time. But getting back to that dome I was talking about in a second, here was the first, these are actually refractors on a dual mount scope with a little wooden observatory. So this was actually the first observatory. I think it was built in, down here, 1894. So this is, 25 years before the DAO. So it's quite early. So, and here's the first sort of permanent telescope that was built there. It's not impressive from the outside, but when you go inside, it's just astounding. It's made out of wood. There's the carpentry alone is a work of art.
Yeah.
And this is actually a 24-inch refractor, at 15 or 14.7 or something like that. Its main purpose was to look at Mars. So Percival Lowell was obsessed with life on Mars. Like he was a very wealthy guy, so he could afford to do all this. he was just wanted desperately to map Mars. And he did a good job of mapping Mars, and a lot of Mars specialists came out of this observatory, but I don't think his main conjectures were proven right. Just a few things about this. One interesting thing, they used to have railway lines to move the dome, like they do at the DAO. But they got, actually in the 1950s, they replaced it with car wheels, with tires. So I thought that was pretty cool. I took a couple of instruments, just to couple of pictures, just to appreciate the dome and the workmanship. It's gone through a couple of renovations and it still works. They open it nightly when conditions are right, so that you can go look through it. It's just fantastic.
Was Lowell completely visual, or did he do photography?
I think there was some spectroscopy on here, but he was mainly he was the focuser, the original focuser for it. He was there. He is.
Oh yeah.
So he was a sketcher, much like yourself. So he spent a lot of time sketching Mars. He even made a little globe of Mars over here on the right.
Oh, the canal.
Yeah. So about 25 years later, like contemporary with the Plaskett, this was their the Lampland telescope. Carl Lampland was named. And it was the one housed in the Jiffy Pop. They made over 10,000 plates of galaxies and clusters. And also discovered supernova with this telescope. Carl Lampland did. And it was actually the Cipher brothers on the right-hand side. These two guys, one of them became director of the observatory. One became featured on Disney's television program Tomorrowland. So he was there talking about Mars and all sorts of things. He became a Mars specialist. But his brother was actually more technically renowned, because he's the one who basically determined redshift and that linkage with the speed of which galaxies were moving away from us. And they did all kinds of spectra. Let's say 10,000 plates of galactic cluster spectra.
Doesn't look like that large a telescope.
Yeah. Did I write down how 13-inch? No. Sorry, that's not larger than that. Yeah, it's nowhere near as large as the Plaskett, and it's sitting outside now, and the mirrors have all been removed, and that dome is actually for groundskeeping maintenance. This was one of my favorite telescopes. So this guy, Clyde Tombaugh, he came from a farm in Kansas, and this telescope, it's been refurbished, but the main tube is a grain screw, an Archimedes screw. This is a cream separator stand. This is a flywheel.
Whatever.
This is a Coke can. This is a tap handle right there. So he made this on the farm. I don't know how he made the mirror, because that's quite an involved process, but somehow he put this together, and he was 23 or something. And he sent in all these sketches to the observatory, and they ended up hiring him. Now, now. Well, that was. So here he is, he's the guy who discovered Pluto.
Yeah.
So, and this is the telescope, this is the 12-inch, he discovered on on this 12-inch. So there's lots of famous astronomers, and I took some pictures of some of the machinery. This was the blink comparator. So this is, you put one plate on each side and you could look through it and it would alternate the view so you could see if something was moving or something was there and then it wasn't.
Yeah.
A very simple thing to do on a PC, but not so easy to do with plates. A couple of things. Here's the clock. It looked quite impressive, and here's their calculator. This is their
Oh, nice.
cell phones. And the other thing I just wanted to show, that was very impressive, was this open deck observatory that they had built. And it's kind of part of the observatory, like it's still their land, but it's almost separate. It was built by donations. The weather is very amenable to do something like this. But this is again open nightly for anyone to visit, and they've got a solar telescope out during the day, but at night this whole building rolls off, and all these various telescopes are placed on different targets, and it's just like a kid in a candy store, right? And the one on the left there, I got that. That's essentially my rig at home. So I was super excited to see mine out.
Did they do a better or worse job than you?
I didn't see, I think most of these are used for observing, right? I think there's one or two that might be used for imaging, but it's really an outreach thing. And this particular telescope, I'm an astrophysics now, but the telescope is just a massive refractor. Right?
Like counterweights.
I really had telescope in. But all this was put together by private donations, and not only is probably more telescopes in there, more glass looking at the sky, but the people are really involved down there. I got that feeling with the astronomy that's taking place.
So between telescope times, that's when they spend their time at the shooting range.
Yeah. Well, it's a mixed slate, I think.
Yeah. It's very
The
purple.
more.
There's.
I just want to read out Lori's little comment there.
So just open the chat.
I'll read it
Oh,
out.
yeah.
Ian McLennan was very involved in designing this visitor center, and he's doing some work for us at the center of the universe, and that's really cool.
Absolutely. In fact, I spent some time, I passed on to Amy. I gave her a card because I talked to a woman who was in charge of the donations at the observatory. I spent some time with her, and I passed on her card. And this new observer center they're opening in November, it's just finished being built now. It's just massive. I didn't get to see it because it's not open yet, but they hired a Canadian consultant, and she offered for us to call her about VAO and private fundraising, but that new visitor center was raised by this Canadian consulting company. Did that, and then they went from this project. They're doing the rebuilding of Kit Peak in the south. They're getting funding for them to rebuild what burnt down there. So it's a link I hope we follow up on. But Lowell himself, died in 1929, and I guess he liked astronomy so much that he built his mausoleum on the grounds in the shape of a dome. Here's the Grand Canyon. It was pretty impressive too. And here's some of the rocks in Sedona, which I highly recommend visiting too. And that's all I had.
Well, that's. I have to quickly share a slide. Here we go. It's Dave.
Yes.
This is.
Oh, is that?
Yeah.
I've seen that one before, but I didn't know which crater.
It's a good thing.
It's one of those amazing coincidences. Yeah. Okay, so yeah, we seriously only have 15 minutes left. Margie, can you get us your picture? And then we have David, and I think that's going to be it.
I actually have a couple of things to say.
Okay, well, let's just check. Margie, are you able to share your screen?
I will certainly try. Okay. So, okay. So it's just like share screen. Click on desktop 1, share.
Hey! Wow.
Oh.
That's not it.
Oh.
That's it.
Ah, there you go.
Can you see that?
Yes.
I think I see somebody standing.
Looks like my
Okay.
So when was that?
So you know what that is?
Yeah, that's Kelly's telescope.
Yeah.
Yes.
Exactly. I took that photo.
When?
I took it in November. I was bird watching in southern Arizona. And I looked up one day as we were driving along in the van and I said, "What is that?" And the two guides who were from Tucson did not know. And I said, "Well, it looks like an observatory to me." So when I came home, I put it into Google Images, and sure enough, Fred Whipple.
Here we go.
There you go.
Great, thank you.
Excellent.
Okay, just
Okay.
wait.
Mr. Lee.
Right. And I don't think this will take very long. So I'll make sure I leave enough room. Leave enough room for Chris. Okay, there we go.
No.
Can everybody see that?
Yep.
Yes.
Okay, so last Saturday I was up at the DAO at one of the star parties, and somebody came up to me and asked me, "I just read about this star that's going to explode," and I thought, I wonder what that is. And I recently read about something, and I wasn't quite sure, but when I went home, I looked it up, and there is a recurrent nova, and I don't know how many people remember RS Ophiuchi a couple of years ago. I think it was in 2021. Remember, I was looking for it and I watched it. Well, anyways, this one last year, they actually detected that there was a dip in its magnitude. And that apparently is kind of a warning sign that within half a year or so, it's about to explode again. So just to reiterate, recurrent nova are not quite as cataclysmic as supernova. In other words, they periodically gain fuel and then come off with these bright explosions. And then they just go back to sleep for a little while. And then they may gather fuel again after a certain period of time. But the time is not absolute. So it's only approximate. So that's why they use these kind of signature things like when the magnitude starts to dip. So normally T Corona Borealis, now this is a star that's just below the northern crown. Now many of you know the Borrealis constellation, the one that looks like a ice cream cone or like a kite. Well, right beside it is a smiley face. Well, that's Corona Borealis. Now, that's not where this nova is, recurrent nova is. It's just a little bit below. So I'm going to leave you with information so you can actually look for this yourself. The magnitude of the star is going to go from 10 up to about 2. So it's probably about almost the same brightness as Polaris. Not super bright, but bright enough to see with your naked eye. So they believe it's going to happen sometime between now and September of this year. So I'm going to keep you guys updated on this. The next few clear nights, I'm going to sort of image for a baseline, and then hopefully this thing will go up to a Mag 2. If you want more information, there's a NASA blog that did some information on it late last year, and the AAVSO is a society that I belong to. They did a whole webinar on it last year as well, which is here. So I'm going to take these links and I'm going to paste them into the chat, and you can look at them at your leisure. Now, this won't be the last time you're going to hear about it. I'm going to tell you as we get closer. It might last anywhere from, I don't know, like a week to maybe 3 weeks, maybe even a month. So we might have a little bit of lead time for it. But in the meantime, for interested parties, please contact me and I'll make sure you know where to look for it. So this is ideal for people that are using binoculars and things like that. Maybe just periodically check it, just like we did with Algol. And maybe we might see a big recurrent nova. Anyways, I'll put this into the chat.
That was cool. And we're going to close with Chris.
Okay. Just a couple of news items here. This is the time of year when budgets come out in the United States, and it's always a bit of a nervous time because, you know, we have certainly at least one party in the United States that's always pressing for budget cuts, which is a difficult thing because most of the budget can't be cut for various reasons. And one of the areas that can be cut is space. So at least in the budget as it is right now, and this is not yet a done deal, it looks like the Chandra X-ray telescope is on the block and maybe shut down in about 5 years. It was sent into space actually 25 years ago on the shuttle, and it's done a huge amount of work, but a lot of people are concerned that you know, if there's if they actually do succeed in closing it down, you know, that's kind of the end of high energy astronomy for a while. Apparently, the same budget contains some small cuts for Hubble, but I haven't heard anybody really complaining about that. So that's one item, and then I have another item here, which is kind of a sad bit of news, which I don't think has gotten around too much. But the other day, we lost my friend here, David Lane, who's a past president of the society, this is a picture was taken in Fredericton about 15 years ago. I'm actually not receiving the award for me. David instituted the President's Award, and the first President's Award went to Sid, but Sid wasn't there, so I accepted it. So Dave was national president around 15 years ago. I know he came out here to speak at least once. Founding member of the RASD, the Royal Astronomical Society of Daves. And he was also known for some of the work he did with computers. You know, he had I think a program called the Earth-Centered Universe, which a lot of us used back in the day. Um, and he had a home observatory. He worked at the St. Mary's University Observatory in Halifax and recently retired from there. But he had his own home observatory that people loved to see because he had it all set up so that he could operate it from a more comfortable spot with computers. You know, I remember getting the tour there once and was most impressed with it. So that's kind of what I wanted to end off with. Yes, you know, and Dave was somebody we would always see at GAs, and I'm hoping that you know, we will be reinstituting in-person GAs because I really, you know, miss some of these people. Fortunately, we do get together with some people thanks to Zoom. Of course, Peter Jedicke is also a past national president, and of course he's often here with us. So I will leave it there.
When did this happen, Chris?
Sorry that you lost your friend. And I
Yes.
heard about the RASD. We should do a little item on that sometime. Maybe David Lee, you could give us a little presentation on that.
Yeah, and you know,
that's right.
Dave
I-
Bennett was quite active in that. and-
Yeah, he was. That's the first I've heard of that, Chris. Was it recent? Really
Well,
recent?
I got a phone call last night, and I expected to see a lot of stuff on the internet today, and I didn't see much. But I'm sure it's going to come up. I actually have now seen a couple of things on his own Facebook, on Dave's Facebook page, but I expect there'll be some more because he was, you know, he was, you know, very prominent in the operation of the society outside of the time he was president. You know, well, I think he chaired the IT committee for quite a while.
He did, and some of the original listservs, I think Dave put up as well, and I think he served a lot of the stuff out of St. Mary's, as far as I
That's right.
remember.
Well, as a matter of fact, yes, the national website was kind of run out of St. Mary's for a long time, and
It was.
But I remember, you know, when I was national president, I was in a pickle a couple of times, and he was able to help me out. So it's you know, he did quite a bit of stuff. You know, fortunately, you know, I had heard that he was not well, although I don't think people expected this to happen just now. But a couple of months ago, he was given an honorary degree by St. Mary's, which I think is a wonderful honor, and I'm glad that, you know, I'm glad he got that because he's very deserving.
Well,
Yeah,
thank you for
that's-
speaking news.
That's shocking. Oh my
Yeah,
gosh.
it is. Yeah.
Oh.
Well, many of us know David for sure.
Yeah,
Right.
yeah.
Many of us do.
Yeah.
A couple of announcements. Next week is Easter Monday. We will not be holding Astro Cafe. The following week, it's just April 8th, nothing important. Anyway, because so many of us are not going to be in Victoria, I still want to hold a little party after the eclipse. So we're going to do it online. Jim Cliff will be the host, but it will be completely online, and Dave Payne will be the recorder. And
If it's a party, do you want it recorded?
yeah, because people, you know what I
Sounds
really want?
boring.
I want to see videos of people enjoying the eclipse. That's my hope, is that we can get to see how people we're going. I'll be in Montreal. It's got like a third of a chance of clear sky, a third chance of completely overcast. Oh well. Some people are being cleverer. Oh, and Chris is showing off the new stamp. Can everybody see Chris Gainor's thing?
Yeah.
I've got my stamps.
It's a very big stamp.
Well, that's, the stamp is up in the corner here. And, but this is like a first day envelope that collectors get.
That's right. It comes in a package of 10. They're still available in town. I found one. Anyway, we gotta go. The custodial staff want to get in here soon. Tomorrow is going to be the meeting of the International Astronomy Day. This link is in the announcement for the Astro Cafe. We'll see you on the 8th, and then in person where you can get cookies if you come in. On the whatever that is, the 15th. I know how to add 7. Okay. Thank you all.
Thanks, Callie. Thank you.
Yeah, thank you.
Thanks, Steve.
Good night.
Bye.
And Miles and Kristen, don't forget that I have your name badge.